Gupta from IT Roorkee, and we will be continuing discussing our top into our series of questions on Leetcode. And our today's question is LRUCache. So let's go to this question and see what it states. So this question states that design a data structure that follows the constraints of a least recently used LRUCache. Implement the LRUCache class. LRUCache int capacity. Initialize the LRUCache with positive size capacity. Int get int key, return the value of the key if the key exists, otherwise return -1. Void put int key int value, update the value of the key if the key exists, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The functions get and put must each run in over an average time complexity. So example number 1 is given as, first we are defining LRUCache with a size of 2. Then we are putting 1 comma 1, this is key and this is value. Then we are again putting 2 comma 2. So by this time 2 would be at front and 1 would be at the back. Now we are getting the value of 1 and that would be 1. So 1 will again move to the forward and 2 would be at last. Then we are putting 3. So when we have to put 3, then already the size is 2. So we'll have to remove the least recently used item, and that is 2. So we will remove 2 and add 3. So now 3 would be at first place and 1 would be at second place. Now we are checking the value of 2. So it would be -1 because 2 is not present. Now we are putting 4. So if we are putting 4, then 1 would be evicted out. Now we are getting the value of 1. So we will get -1 as it is not present. Now just 3 and 4 are present. Now we are trying to get the value of 3, so it will be 3, and then we are trying to get the value of 4, so it would be 4. So in this way this problem is structured, and capacity can vary from 1 to 3000, and key value can go from 0 to 10 to the power 4, and value can go from 0 to 10 to the power 5, and at most 2 into 10 to the power 5 calls will be made to get and put. So this is the question, and in order to implement it, we will have to first define one linked list. So it will be a doubly linked list which will have pointers to the next pointer and as well as previous pointer, and in that we will store the values of each of these key value pairs, and we will also define two maps. One map will store the value of this key and value, and another map will store the mapping of this key with the linked list pointer. So when we'll go to the code, then we will be better able to understand how we are implementing it. And we will also have one variable which will keep a track of how many what is the size which we have already used, and we'll also keep a track of variable of total size which we are allowed to use. So let's go to the code and try to understand it well. So we are defining this class node. It will have integer value and node star next and node star previous, and then we are defining this node constructor int x node star next node and node star previous node, and we are assigning the value. So this is a doubly linked list, and then we are defining node star head is equal to null and last is equal to null. So we are keeping track of the head pointer and the last pointer. Then we are defining our two maps, map m and node map, and then we are defining len as 0. So this would keep a track of what is the total size, and current len will keep it a size of how many elements are already inserted. So then we have to define this function LRUCache int capacity. So this will initialize the total size of our system. So this will become as len is equals to capacity. Now we'll write the code of int get int key value. So we'll check if this key is this code will run when this key is already present. So if this key is not present in our map, then we'll directly return -1. Otherwise, if this key is present, then we will get the current node from this key. So that would be stored in node map, and then we will check if this current node is already at head, then we don't need to do anything. But if it is not at head pointer, then we will have to move this current node to the head, and we will do this by this code, and then we will finally return this m of key. For implementing this put function, we will have been given this two parameters, int key and int value, and then we are checking if head is equals to null. It means that there are like this is the first value being inserted into our doubly linked list. So we'll define head as new node, key null null, and last as also head, and we will insert the values into both the maps. So m of key will become value and node map of key would become head and current len plus plus, and then we will return. Else we will check if this key is present in our map, and if it is present in our map, then we will take out this current node from this using this mapping node map, and then again we'll have to shift this node to the first position if it is not equals to head. So we are doing that, and then we are updating the value of key to the value. Else means if this key is not present in our map, then we'll check if current len is less than len. So it means that we just need to insert this key in the front of our doubly linked list. So we'll define this new node and we will insert into the front of the doubly linked list. Else we will insert it into the front of doubly linked list, and we will also have to remove the last element, and we will erase that last element from both of the maps. So this is the code, and I will attach this code in the comment section. So let's try to run it and see whether it's working fine or not. So this is getting accepted here. Let's try to submit it as well. So this solution is working fine. I will attach this code solution in the comment section of the video, and I will also attach this problem link and problem description in the description of the video. So like this video and subscribe to my channel for more such top into 150 series of questions on Leetcode.